All right, everybody. This is kind of a second part to how you can use Desmos um, efficiently and effectively for our class. Um, kind of talking through just specific reference. We're in our second unit, which is that cumulative unit 3, and it involves some piecewise functions, graphing them, evaluating them, finding the domain of them. And so I wanted to, again, show you how to use Desmos with those. It is slightly complicated, um, but it's very similar to that if you want to use Desmos and you know the formula or the fill in the blank process of how to graph them, then it is still a lot faster than trying to graph it by hand for a lot of you. And so I wanted to show you that, and I'll post it on Wolfden as well so that you have access to it. But anyways, here you go. So again, from your second mock test, to help you prepare for your cumulative unit 3, that was our second test. I have this problem somewhere in that mock test. It's a piecewise function, meaning there are two pieces of functions, and they're going to be represented on a graph with different domains. And so I want to show you how to graph this so that you can answer a variety of questions like, what is the domain of this piecewise function? Or evaluate the piecewise function when x is -4. And you can use the graph and go right to your answer instead of panicking because there's a lot of exponents and a lot of pieces staring at you. Yeah, so just to save you some time. Anyways, here is the formula, if you will, for how to type these in. I'm seeing if I can do this in such a way that it will be easy. I guess I'll just type it over here in Desmos. So with Desmos, just like you would with a lot of things, graphing in Desmos, you're going to start out typing it exactly how you see it. That's how I've always described using Desmos. And so I want to continue using it, using that language when possible. However, the one instance where I have found that you do not type stuff in exactly how it is written for you in Desmos is when you are graphing piecewise functions. But here is how you do graph piecewise functions using Desmos. It is still simple if you have this structure or like this fill in the blank system written down. So here it is. It is a function, so f of x equals, if you want to put y equals instead, you can, but it is a piecewise function. So I'm going to use the function notation. So for the first piece, this top piece of the function, I'm going to start with it. I'm going to use a brace, which is the little squiggly. If you press shift and bracket, that's where you're going to find it on your keypad on your computer, most likely. You're not going to use a bracket. You're not going to use parentheses. You have to use a brace for this to work. So make sure you find that icon or that symbol to start out typing. Now, the next thing is that instead of just typing the function exactly how it is written in the problem, you actually have to put the domain piece first. So what I mean by the domain piece, I mean the inequality part. So whatever the inequality is for the top piece, that's what you're going to want to type. Desmos is making this as a fraction. So domain or the inequality piece first. Okay. Then you're going to have to use a colon. Okay. On my computer, that's shift and semicolon. Big shocker there. So find your colon, and that's what you're going to put in right after that. And then you'll actually put the function that's right here. Okay. So f of x equals, on Desmos, you'll do a brace, type the inequality piece first, colon, then the function piece. And then lastly, close your brace. And then you would do that again for the second piece as well, and so on and so forth. So for this piecewise function, there's two pieces. So I'm going to have f of x equals another brace, that second domain or inequality piece, colon, and then its function, and close the brace. If you end up looking at a piecewise function that has 3 rows in it, then you would just come over here and type a third row. Okay. All right. So to actually graph this piecewise function, I want to actually graph this one with you. So f of x equals the brace. Again, I'm going to do that first row, and based on my formula, if you will, or my fill in the blank thing over here, I have to do the inequality piece first. So I've got to type x is greater than 2, colon, and then my actual function. Okay, and my actual function is x squared minus 4x plus 2. And close your brace. So there's the first piece of your piecewise function. Now we need to do the second piece. F of x equals, just like up here, open another brace. Take the second inequality row, so right here, type this inequality piece in. So that's going to be x is less than 2, colon, and then type that function piece in the second row. And you can type them down here using Desmos' keypad, or you can type on your actual laptop keypad. I'm kind of doing a combination of both. So on my keypad, I'll do negative parentheses, x minus 1, close parentheses. When I have to type the squared, I just come right down here and I hit that button. And then make sure that you don't forget the minus 1. Anytime you're using Desmos, always make sure that what you've typed, like that function, make sure that it matches up with the function piece that's given to you. Okay. All right. That's all that we have for our piecewise function. So I'm going to scoot the typing off to the side, and I'm going to actually look at my graph. Okay. And just like in our other helpful video, I can click on the piece and I can scroll or drag my mouse all the way around it. Notice there's one key point there at 1, -1 for this function. Notice also that Desmos has these color coded. So if I bring my equations back up, the black piece of the function matches with this black spot over here. So any values in this black here are coming from this black portion of the piecewise function. If I'm looking at coordinate points over here in purple, so like 3.4, 0, that x value is found in this purple section of my piecewise function. Okay, so what does that mean? Well, what if I ask you to evaluate this piecewise function? So evaluate this piecewise function at f of -2, which means when the x value is -2, what is the y value? Okay, so come over here, look at your graph, find the x value of -2, and then you're going to scroll down. You might have to drag your mouse some, but you're going to scroll down until you find when x equals 2, what is the y value? -10. And so f of -2 equals -10. If you were to do this algebraically, you would have to look at your functions and say, if the x value is -2, which piece does this fit into? Is -2 greater than 2? Nope. So the top row is out. Is -2 less than 2? Yes. So then I would use this piece of the function and I would plug in -2 for the value of x. So -2 minus 1 is -3. Squared is 9. Times the -1 is -9. Minus 1 is -10. And that is exactly what we got just by graphing it. -2, -10. So the moral of the story is, here's how you graph piecewise functions on Desmos. Here's how you can evaluate piecewise functions graphically And here's how you can check your algebraic evaluations of piecewise functions using a graph. Okay. Bottom line, right up here is that formula, or that the format of how to type into Desmos a piecewise function and graph it. I hope that that is helpful for you. The other thing that you can always look at is the domain. So now that you have the piecewise function graphed, what's the domain? Well, the domain is a set of x values. In that case, x values are horizontal. So we start from the lowest x value possible over here on the left, which is negative infinity. And I move to the largest x value. So keep going, negative infinity all the way up to, we might be tempted to stop there, but look, we have values that exist right there. The black one exists at -2, the purple does not. But if there is a single x value at 2, then we keep going. So this graph is continuous, meaning I don't have to pick up my pencil because there is a value at 2 and beyond. The domain of this piecewise function is negative infinity to positive infinity. So again, instead of doing it algebraically, if you need to find the domain of a piecewise function, you can also find it graphically.